Video lesson 2.1, angles and lines at a point. Now, when dealing with Unit 2, there's a lot of vocab that goes along. A lot of these things you should have seen between grades 4 and 9, symbols and vocabulary and explanations and stuff like that. But just to cover, make sure that everyone's on the same page, let's review some of these and kind of get into more depth of some of these things and what we can use for. So one of the first ones, very important angle, are vertical angles, right? These are angles that are going to be equal to each other in measure. As you can see down here, I have the abbreviation for vertical and then the angle symbol. Again, a very important symbol, one we will use often. So it is important to know that that indicates what the angle is. Over here in the diagram, right, two intersecting lines create vertical angles. That would be here angle B and here angle A. Those would be vertical angles. And with those vertical angles, we now know that those things are equal in measure. How we're going to describe that in a proof or in our terminology, generally speaking, we refer to it as vertical angles are congruent. Again, another key vocab word here, congruent. That does mean equal in measure. So important stuff to know there. Next one would be adjacent angles. All right, so adjacent angles are essentially just two angles that are next to each other. They share a common vertex, and they are sharing the same side. So in this example here, if I can highlight these two, we've got this first angle here, angle AOC, which would be this one here. And then we have a second angle here, angle COB, which would be this angle here. And as you can see, those two things, they share a common side. They are both sharing, I'll highlight it here, this one side here. Let's use a different color, that's a little dark. There we go, a little bit better. They're both sharing this side. Therefore, they are adjacent. They are next to each other. All right. Other things are important to notice is that we have this expression here that angle AOB, that would be the big angle, is equal to these two smaller angles added together. All right. Again, terminology-wise, this is referred to as the angle addition postulate. When I take two angles, add them together to make a larger angle, but we'll get into a lot more depth of that when we actually do proofs. Next one, supplementary angles, another very important angle terminology. These are two angles that form a linear pair, aka they form a straight line, and those would be add up to 180 degrees. So in this example here, again, if you can highlight these two angles, we've got this first angle, which is being indicated by this letter here of angle A, and then we have this one over here, which we're indicating with the angle, which is angle B. Again, those two angles together, they form a straight line, right? That angle there, they form this straight line right there. So therefore, the two angles add together, they make 180 degrees, right? That's the definition of what supplementary angles are. So again, in our concept, linear pairs form supplementary angles. And again, when we get into proofs, we'll get a little bit more descriptive as in terms of how do we word that. But supplementary angles, again, add to 180 degrees. So that's an important one to know here. They add to 180 degrees. Another angle relationship is consecutive angles. This one can get a little confusing because consecutive means just one after the other. It does not necessarily mean it has to form a straight line, though in this example we do have one that creates one. So we've got a lot of angles here. So we've got angle A, we've got angle B, we've got angle C, and we even got angle D here. So all four of them, yes, all four of those angles do in fact create this. If you add those all together, they do form this straight line here. Again, that's not necessarily always the case. So they don't always, consecutive angles don't always add up to 180 degrees. It just means multiple angles that are going to add up to each other. So it's important to know that consecutive angles, in this example, consecutive angles on a line add to 180 because they all do. But if you just take for a second here, let me just erase this for a second. Like, what if I only said or wanted to identify angle A, angle B, and angle C, those are still consecutive, but when you were to put these three together, right, to form a line, like if I was just looking at this big angle like that, that's created by those three, not 180 degrees. Yet angle A, B, and C are still consecutive. So that's got a little trickiness to it. So you do have to be careful when dealing with that type of an angle relationship, and it can be kind of unique to each scenario. Next one is angles at a point. This is when the sum of all the angles together coming together at one point, they add up to 360 degrees. So all the angles are going to share the same vertex, aka the point where the angles meet. And in this case, you're going all the way around. So if you look at it here, you've got this angle here, angle ABD, right there. You've got angle DBC right here. And we've got this last angle here, ABC, this one. You notice that if you were to go around here, 1, 2, and then 3, you make a circle. Again, all three of these angles added together get you back to where you started. Therefore, it's 360 degrees. So they're going to add up to 360 degrees. So which is indicated here in an equation format in this expression down here. One other little important note, and we'll talk more about this in class, but again, here's how you label an angle. Angle symbol, and then the three letters that go along. So example A, B, C. B being the vertex, that's the one in the middle here. The little M in the front, that just stands for measure. So if I'm talking about the value or the size of it, I'm talking about the angle measure. If I'm just referring to the angle itself, I don't need the M in front, but if I'm referring to the actual value or size of it, then I utilize that little M in front for those. All right, and again, terminology-wise or expressions when we're dealing with proofs later on, we get angles at a point add to 360 degrees would be one of the ways that we would express that. All right, another angle relationship that we're going to focus on for this video, and that is complementary angles. This is similar to supplementary angles, but instead of the two angles adding to 180 degrees, these two specifically add to 90 degrees. So complementary angles, they add to 90 degrees. So in this case, I've got one angle here. I've got the other angle here, right? And they make this big angle, which is 90 degrees. You also can tell because we have a right angle symbol, which is this little box symbol here. Make that a little better. There you go. And that indicates that I have a right angle. Right, so with that right angle, I now know that it is 90 degrees. So this, let's call this angle, for argument's sake, we'll call this angle A, and we'll call this angle B. And again, these two angles together, they create a larger angle, which is this yellow one, and that's a 90-degree angle. All right, so again, one of the expressions or terminologies that we would use would be complementary angles add to 90 degrees. All right. So those are important things to know. Other things that we would want to be able to do is actually solve some of these things. So it's important to be able to identify them. So in this case here, this first example, hopefully you can look at this and say, oh, I see two intersecting lines, one here, one here. That means that the angles created here are vertical. So I've got vertical angles. In this case, I've got this one here, which is 36, and I've got angle X over here. I also have these two, which are also vertical, but we're not dealing with them in this case. So this angle here, 36, and X, so that means X is equal to 36 because with vertical angles, they are congruent. So we now know that if this is 36, this is also 36. So easy one if you know that term and that expression of what a vertical angle is. If you look at example 2, we've got here, again, we got a straight line with a ray coming out of it, or you can identify it as two separate angles. So we've got this angle here, angle Y. We've got this angle here, which is 120 degrees. So if I'm looking to find out what Y is, I can say this angle plus this angle. Since it does form a line, I know that this is going to have to add up to 180 degrees. So I can say Y plus 121 has to equal 180. And then I can just use like regular solving equations. simply subtract them and figure what value would be for y. So in this case, if I subtract that, I get y equals, what is that, 59 degrees. And there I go. All right, example number 3, we have here, we've got angles at a point. Again, I've got 3 angles here, angle Z. I've got one other angle that's 82, and I got a third angle, which is 172 degrees. So again, all intersecting at the same vertex for each of them, and they go all the way around. So I get a situation here of angles at a point where they all going to add up to 360. So I can take all of my angles, add them up, and say, well, together they have to equal 360 degrees. So I can make my life a little easier. Add these together. So Z plus 254 has to equal 360. If I subtract the 254 from both sides, that's going to get me Z equals 106 degrees. So again, if I just create a little equation there, makes it easier to kind of solve what that is. All right, last one we'll do here for the video, we are getting a little long here, is this example here. Now, again, this is what we're going to talk about more tomorrow, and how these can kind of, these diagrams can kind of get a little bit more involved, and you can sometimes have more than one thing going on inside the diagram. So if I'm looking here to find out what x is, it's first glance, I'm looking here, and I like to look for vertical angles whenever possible. I say, oh, are these across from each other? This 4x minus 10 angle and this x angle. Unfortunately, they're not directly across from each other, so therefore they're not vertical. But I do notice that this angle and this angle are. So if this is x, I could call this x also. And I do notice here that I've got, let me highlight them. I do have this line here and this line over here, right? And they're indicating that it's 90 degrees up here. So that would mean that this section, B to the center to D, would also have to be a right angle. So we could indicate that that's also a right angle there. So if that's the case, then I have these two angles that are next to each other, this x here, let me do it in blue here, this x angle there, and then I got the x plus 10 angle here. Together, they have to be 90 because they're forming a right angle. So now I could come down here, make a little bit more space. I can say that x plus 4x minus 10, since they're complementary angles, I know that they have to add to 90 degrees. Now I can have an expression like this. Again, make your life easier, combine like terms, 5x, add the 10x, the 10 over, I'm sorry, so that we get 100 on the right side, divide both sides by 5, x is going to equal 20. So that's x, the value of x. So x is 20 degrees, so that means that this angle is x, so that means this is 20 degrees. That's one of your answers. And if I was to plug this one in over here, 4 times 20 is, all right, minus 10, so that means that this one over here is going to be 70. And again, that makes sense because 70 plus 20 has to give me 90 degrees because they're complementary. All right, so this video ran a little longer than I wanted to, but hopefully you guys understand what's going on. You make sure you copy down all of the important vocab words and their definitions, and you practice these examples here.